Welcome back. The objective of this video is to spend some time with the secant, cosecant, and cotangent functions and how they relate to the unit circle. We'll also spend a little bit of time doing some graphing or finding these functions from a graph. So the challenge here is use the unit circle to find the values of these reciprocal relationships. So in A, we have a secant function, which is the reciprocal of cosine. So we know that this is 1 over cosine, so we should be thinking x. For the cosecant, that's the reciprocal of sine, so this one we're thinking y. Cotangent is the reciprocal of tangent, so we should be thinking x over y instead of y over x. And here again for D, we have the secant, which is 1 over the cosine, so we're thinking x. So 13 pi over 3, we think about our unit circle and we rotate around until we end up back here at point A. So the ordered pair for the secant of 13 pi over 3 is at 1/2 square root of 3 over 2. So since we want the reciprocal of the cosine or the x value, that answer is 2. For B, we want the cosecant of 17 pi over 4. 17 pi over 4, we rotate around and around, and we end up at point B. We end up at the ordered pair at the square root of 2 over 2 and square root of 2 over 2. So we want the reciprocal of our y value, which is 2 over the square root of 2, or 2 square root of 2 over, that'd be 2 square root of 2 over 2, which cancels, so we get the square root of 2. For C, we're going to rotate till we get to 9 pi over 2, which ends up again at pi over 2. So our ordered pair there is 0, 1, and we want x over y. So that's going to equal 0 over 1 or 0. And then finally for D, we're going to rotate in the negative direction. Negative 17 pi over 6 lands us in the third quadrant at point D. It lands us at the ordered pair negative square root of 3 over 2, negative 1/2. So we want the reciprocal of the x function. So that would be negative 2 over the square root of 3, and then rationalized, that is going to be negative 2 square root of 3 over 3. So I move my unit circle out of the way, rationalize that guy, and we get negative 2 square root of 3 over 3. So we've got all of our 4 answers that we got off of the unit circle. In the next portion here, it says, can we name the reciprocal identities and quotient identities in terms of a trig function? Well, we just did that. The cosecant is 1 over the sine of theta. It will be helpful for you to know that sine is y over r, so the cosecant is going to be r over y. Okay, but this is what she really wants right now. The secant is 1 over the cosine of theta. It will also be helpful to know that that is y over x, and the cotangent is, of course, 1 over the tangent of theta, which then would be x over y. So both of these columns are going to be important for our studies. For quotient identities, they want us to write tangent in terms of sine and cosine. Well, we know tangent is y over x, so that means it's also the sine of theta over the cosine of theta. And then, of course, cotangent's the reciprocal, so it is x over y, so it would be the cosine of theta over the sine of theta. Example 6 says, find the exact values of the 6 trig functions of an angle theta if our point is at negative 2, 5 is on its terminal side. So negative 2, 5, we're in the second quadrant. Our x value is negative 2, and our y value is 5. So our theta is squeezed between the x-axis and the terminal side. We just need to find our r value. And we'll do that by doing the Pythagorean theorem. So we have -2 squared x squared plus y squared equals r squared. So we have 4 plus 25 is 29 equals r squared. And when we square root both sides, we get r is equal to the square root of 29. And since r is always positive, we'll disregard the negative square root of 29, or the negative, and we can do all of our trig functions. So the sine of theta is equal to 5 over the square root of 29, which means our cosecant of theta equals the square root of 29 over 5. Now we can rationalize this guy, and we get sine of theta equals 5 square root of 29 over 29. I'm going to have a hard time squeezing this in. Our cosine of theta is going to be x over r, or -2 over the square root of 29. So then our secant of theta equals the square root of 29 all over -2. Rationalized, that would be -2 square root of 29 over 29 for our cosine. And then our tangent's going to be a little bit easier. It's going to be y over x, or 5 over -2. And our cotangent will be -2 over 5. And that should be of theta. Example 7. Given the sine and the cosine are these particular values, find the exact values of the 4 remaining trig functions. Well, we can flip these right away to get our cosecant and our secant. Something sneaky has gone on here, though. You may or may not recognize that these have already been rationalized. So if I unrationalize, if you will, the sine of theta, that would be 2 over the square root of 13. And our cosine of theta unrationalized would be 3 over the square root of 13. That might be a little bit easier for us. So then we know our r value is the square root of 13, and our y value is 2, and our x value is 3. And our theta is here, and sure enough, 9 plus 4 is 13, so that does meet the Pythagorean theorem. So my x value is 3, my y value is 2, my r is the square root of 13, and we can do the rest of our trig functions. So our cosecant of theta will be the square root of 13 over 2. Our secant of theta will be the square root of 13 over 3. And then our tangent of theta is going to be y over x, which will be 2 over 3. So our cotangent of theta is the reciprocal 3 over 2. In example 8, we're asked to write 2 different equations using cosecant and secant. I've taken the liberty to sketch in our zeros and our 1 points here, and let's figure out what our sine and cosine curves are, and then from there we can figure out what our secant and cosecant curves are. So one option, we know our sine curve starts at 0, so we could, if we wanted to, start at pi over 2 here. We could start at -3 pi over 2, we could start at -pi over 2, but if we start here at pi over 2, I could start sine right here, and we could follow a sine curve and give us this particular function. So our sine curve has just been shifted pi over 2 to the right. So for sine, we would have y equals sine of x minus pi over 2. So then our reciprocal function would be y equals cosecant of x minus pi over 2. So now we have one of our graphs. Now we should do one for cosine. So we know cosine starts at at 1. So we could start here at pi for our cosine curve. We could start our cosine curve here at pi. And we could say, well, that my cosine curve is y equals cosine of x minus pi. We could do that. We could even start here at, we could start our cosine here, and we could say cosine equals, well, it would be -1. That'd be negative cosine of x. We could do that too. So that would be y equals the opposite of secant of x. It would be that easy. So this one would just go to that one. So there's one possibility for the cosecant and a secant curve. And of course, for this one, we could have done y equals secant of x minus pi as well. For B, it says write two different equations using the tangent and the cotangent curve. So let's take a look at this and see how things have shifted around. So first, let's take a look at one cycle here and see how long it is. It does turn out that our period is pi. And this seems like just a normal cotangent curve. But we could have shifted like to -pi/4. So let's take a look at that. If that is our cotangent curve, normally is graphed between 0 and pi. So we've taken our cotangent curve, we've shifted it pi/4 units to the left, and that's really the only thing we've done. So that would be y equals the cotangent of x plus pi/4. Now, as a tangent curve, that's going to be a different beast. Let's think about that as a tangent curve. Well, the tangent curve and the cotangent curves are negative. So a cotangent curve is just a negative tangent curve. And this then, as a negative tangent curve, since our tangent curve normally goes between -pi/2 and pi/2, now we've shifted this to the right. So that would be x minus pi/4 for our tangent curve. So those would be possibilities for graphing the cotangent and the tangent in that exact same function. And we'll get some more practice with working with these reciprocal functions and these phase shifts when I see you in class.